Today we're going to talk about power in circuits. The definition of power is the amount of energy transferred per unit time. The definition of a circuit is a closed pathway that allows electricity to flow from one point to another. Here we have a basic circuit. Over here we have our battery, and over here we have our light bulb. For the battery to be able to light the light bulb up, we have to have it connected by wires in a complete circuit. Here we have our positive end and our negative end of the battery. These are both connected to wires. Electricity comes from the flow of electrons through these wires. As you can see, the electricity flows from the negative end of the battery all the way around here, lights up the light bulb, and then flows back into the positive end of the battery. And this cycles. The definition of power, like we said before, is the electron flow per unit of time. If we have a closed circuit, it will allow for electrons to flow. But if we have a broken circuit or an open circuit, it will not allow the electrons to flow because these electrons can't get from here to here, and so the light bulb won't light up. The units of power are joules per second, or watts. I'm sure we've all seen the 40-watt light bulbs at the store, but I'm not sure we've ever realized what that means. That means that 40 joules of energy are passing through the circuit in 1 second. That means that in this circuit, if this is a 40-watt light bulb, 40 joules of energy are passing through here every second to light this light bulb up. In circuit diagrams, we have symbols for different things that allow us to show what they are in a really easy way. So over here we have our battery, represented by this symbol. Here we have our resistor, represented by this zigzag line. A conductor is just a straight line, so that would be like any wire that we're using. A capacitor would be this here. A lamp, like the light bulb we saw in the other, would be like this. And a switch would be like this, showing that we can open and close the circuit with the switch. Let's look at an example. So for this example, we're going to use this 151 electronic project kit that I borrowed from my dad. It's a vintage kit from about the 70s, bought from Radio Shack. And in this circuit that we're going to create, it has 3 resistors, 3 capacitors, one 3-volt battery, which consists of 2 AA's, 1 speaker, and a transistor. Now, these different components will give us the unique result that we're going to see at the end of this example. I'm just connecting the different components with simple wires.
And as I complete this circuit, there should be something that happens. And now because this circuit goes to a speaker, it's creating the sound that we're hearing. And the chirping sound is created by the different combination of resistors and capacitors. And this causes an oscillation that causes the chirping or the sound to momentarily pause, which causes the chirping sound that we hear.
Alright, now let's look at a diagram of that example. Here we have our components laid out in a basic circuit diagram. So as you can see, we have 3 resistors, and the resistors convert some of the energy to another form, causing there to be a drop in the amount of energy that actually reaches the speaker. It also has 3 capacitors in it. A capacitor stores energy in the form of an electrostatic field between its plates. The numbers with it shows how much energy the capacitor can store between the plates. This circuit has a 3-volt battery, as was stated, which is made up of 2 1.5-volt AA batteries. And in this circuit, they are the power source. The electrons flow from the negative end of the battery and flow around the circuit until they reach the positive end of the battery. This circuit has 1 speaker in it, and this speaker is what converts the electrical energy into sound waves that our ear can hear. And finally, this circuit has 1 transistor in it. It can work either as an amplifier or a switch. In our case, it's working as a switch, turning the circuit on and off between chirps, creating an oscillating circuit. But what is an oscillating circuit? We know it's what created the chirping sound, but what exactly about the oscillating circuit creates that. So in this, the base capacitor is charged through the transistor during the time when the transistor is on. Like I said, it's working as a switch, so during the time it's on, it's charging that base capacitor. And then during the off time, this charge causes a positive voltage at the base to turn the transistor off until the control resistances discharge the voltage, and then the transistor can turn on again. The 100 microfarad capacitor in the circuit, that can be found right here, accumulates positive charge from the 0.02 microfarad discharging current, which is up here. 20 nanofarads is also equal to 0.02 microfarads. And it's discharging the current until this voltage is sufficient to turn the transistor off again for a period of time. So that's what creates our sound, is because we have the power flowing at a time, and then the transistor's turning it off again, and then it's turning it on again, and then turning it off again, creating that chirping sound. Because there's not a constant beep that we hear, we know it's an oscillating circuit like this, and this is how it works. So let's review what we've learned and why it's important. So we know that power is the amount of energy transferred per unit of time, and that's typically measured in joules per second or watts, which is what we see when we go to the store to buy a light bulb. Again, a 40-watt light bulb would be transferring 40 joules of energy per second in that circuit. And the circuit is a closed pathway that allows electricity to flow from one point to another. And here we have our basic circuit that we were looking at before. And we can see how the electrons are flowing from the negative end of our battery around and then back to our positive end, because this is a complete circuit. If it weren't complete, this wouldn't be able to flow. We have to have a full, good connection to allow for those electrons to flow. And then finally, we learned about the different components of a circuit. We learned about batteries, resistors, conductors, capacitors, lamps, switches, and all of these are different ways of changing the power that makes it to either the speaker or the lamp or whatever is giving our output. And these components are really what gives us a variety of different products, because we have so many different products in our lives that we use. These transform the power into ways that are useful for us. So in the video example, it was to create a chirping sound. We can use it to create different brightnesses of lamps. And so that's why this is important to understand power in circuits, to understand that the power is the amount of energy transferred per unit time in a circuit, which is a closed pathway that allows electricity to flow from one point to another, which really allows for us to have different variety in the products of our lives. Thank you.